This is SciByte, episode 128 for April 29th, 2014. Hi, everyone, and welcome back to SciByte, Jupiter Broadcasting's weekly science podcast, live on a Tuesday and fresh on a Wednesday over at jupiterbroadcasting.com. My name is Chris, and joining us every single week is our host, Heather. Hey there, Heather.
Hey there, Chris.
Hey, Heather, happy science to you.
Happy science.
So, what are we going to talk about today?
Today, we're going to take a look at regrowing auditory nerves, growing cartilage, a cold stellar neighbor, viewer feedback on the Opportunity Rover, curiosity news, and as always, take a peek back into history and up in the sky this week.
Well, that sounds pretty exciting. Why don't we kick it off with the news? Okay, Heather, what is our first stop on this science train tonight?
Researchers have, for the first time, used electrical pulses delivered from a cochlear implant to deliver gene therapy, successfully regrowing auditory nerves.
Wow.
So cochlear implants are where they're able to input some wires into the ear. It's for specific types of hearing loss. They're able to read the sounds like a hearing device, a hearing aid, except for instead of amplifying the sound, it changes it into electrical pulses and feeds it into the brain so that the brain can actually hook up with the signals that way.
Wow.
So what they're doing now is they're being able to use this actually surprisingly efficient, as they quote specifically, to use gene therapy to administer auditory nerve directly to those locations. So we've been able to see for a while that auditory nerve endings do regenerate if a specific type of protein that's used for the development of those survival of neurons, if those specific proteins are delivered to that portion of the inner ear. So until now, there hasn't really been a safe delivery method that can go straight to the location that they want for drug delivery or viral-based gene therapy. But what they're doing here is they're finding a way to use these electrical pulses delivered from the cochlear implant to deliver DNA to those cells close to the arrays where the electrodes are implanted, so right near the auditory nerve locations. And these cells can actually then produce those neurotrophins, which produce where production is dropped away after a couple of months. But when they're applying it, they can actually change the hearing nerve. That could actually be a way to maintain ongoing activity for hearing generated from the cochlear implant. So not only could it, as of right now, it's a few minutes for the implant procedure, and possibly this, as of right now, is starting to trigger the auditory nerves. So, this would allow much more clearer range of tones, so you could actually get into music.
Wow.
Because they do well with speech, but pitch is not really well for cochlear implants. But in this case, you could start including pitch and other things like that.
So, I guess this is going to restore somebody's ability to hear if they have partial hearing?
Yes, it's for specific types where I think it's more like hearing loss as for age progression or disease of some sort of degenerative nature.
Right. Wow.
So this is kind of a way to, and in fact, they're kind of taking this in other ways and saying, well, this type of technology could actually use for other types of brain stimulation. They say, maybe even for Parkinson's or things like that, where it provides opportunities for fairly safe, directed gene therapy for specific neurological disorders so that you can get right to the location.
Wow. That's amazing, Heather. And of course, the chat room is asking, we'll have links to everything in the show notes for this. Any other thoughts on this story?
No, it's just kind of very exciting as we take steps forward to sort of help any sort of the senses actually for loss that you're able to come back.
Yeah, absolutely. All right, Heather, I want to stop right here and give everybody a little heads up about something pretty neat that we're going to start doing. I think is a regular thing, and it kicks off this Sunday on the jblive.tv stream. Now, everybody that's listening probably knows about the faux show, right? You all know about the faux show. Well, we've decided with the new JB1 studio, the first faux show we're going to record, we're going to start recording them on Sundays on the jblive.tv stream right after the Linux Action Show. So Linux Action Show will finish, and now that I won't be doing the editing, we have decided to slot the faux show directly after last, and that way the folks that are watching last get a little extra after show, and it sort of makes our weekend a little more efficient. That way we're not spreading 2 shows across Saturday and Sundays. So how would you know about something like this? Well, of course, you're listening to SciByte. That's how you found out. But if you weren't listening to SciByte, you would always find out about these kinds of calendar changes over at jupiterbroadcasting.com/calendar, where we put our live production times up there. And the great part is it converts it into your local time zone. So it also saves you from having to do time math. You're welcome, Internet. So to catch the faux show after the Linux Action Show this Sunday, we're going to do a fun gaming edition of the Linux Action Show. I'm hoping to have like a Team Fortress match with the chat room, so we'd love to have you join us and shoot us in the face over at jblive.tv on a Sunday. I think it's going to be a pretty good time, and catch the faux show at its new time slot. But Heather, with that done, that means it's time for the News Bite. Okay, Miss Heather, what are we talking about in the News Bite?
The first example of living human cartilage grown on a laboratory chip has now been created by scientists.
On a laboratory chip, huh?
Yes, well, the ultimate aim of this is to be able to 3D print cartilage.
Oh.
I mean, somebody in the chat room a few minutes ago talking about, cartilage for the ear being regrown. But this is for any type of cartilage in this specific case, so that you could actually build up on your own, take a patient's stem cells and actually build cartilage on top of that. Now, that could be used for osteoarthritis or joint diseases or injuries. Now, in the case of osteoarthritis, it means that you have a gradual disintegration of cartilage. I mean, that could be in any joint. I have family with these problems, and it gets to the point where it just gets to be bone on bone. And it's one of the leading causes of physical disability in the U.S., actually.
Oh.
And some of the treatments, relieve some of the symptoms, but there is no cure. Now, you actually can get to the point where you have joint replacement. Again, I know people with that. But in this case, it could be the ability to replace that cartilage could be a complete game changer. I mean, everything from, those type of arthritis, degenerative diseases, or injuries in any sort of fashion. But I mean, in order to create this cartilage, you need 3 basic elements. You need some stem cells, you need biological factors to help the cells grow into the cartilage, and some sort of scaffolding to give it shape. Now, in the case of 3D printing, you could actually achieve all 3 in the way that the solution is printed out. Now, other researchers have kind of experimented with this type of 3D printing for cartilage, but in this specific case, it's a step forward because it uses visible light to harden it. Other types require UV light, which can actually be harmful to living cells. So, you input it somewhere into the body, and then you UV light it. So it solidifies that, but it might hurt other parts of the body. But in this case, it's just visual light. Now, so this really takes a step forward. And the big deal about being a tissue on a chip means you can have this sort of interface. Now, not only for building things to help put in the body, but it's a test bed. So you can learn about osteoarthritis development, possibly help develop new drugs. And so, and then you could take this and you combine it with some nanofiber spinning techniques, and you can get into all sorts of robust scaffolding to create cartilage that would actually resemble natural cartilage. We're kind of getting closer and closer to that. And a way that they could possibly, thread a catheter through, print out new cartilage right where it needs to be, and harden it.
Wow.
So if you have any sort of disc where cartilage is that is, gone or broken, you can go in, add to it or replace it, and then harden it, and you're practically, much better, almost as good as new.
That's incredible. I mean, you think about the potentials for hospitals and all the things that they could help fix right there on the scene if they had these kind of technologies on demand.
Yeah, I mean, I know somebody who wrecked a bike, their motorcycle, and kablamo, there goes a knee.
Mm-hmm.
And now it's stitched together what you can, and cartilage is sort of waving the hands. But in this case, you could actually go in there and fix, or people with arthritis, instead of having, joint replacement, maybe they could go through and just add back in the cartilage.
Right. Wow. Well, it seems like that's a little bit of the future right there, Heather, that we're just getting a little glimpse of. Very good.
Yes.
Any other thoughts on that one?
No, just kind of looking forward to how quick this can go forward.
Well, then you know what that means. I think it's time for the 2Byte News. All right, Heather, what are we talking about in the 2Byte News?
All right, a brown dwarf star has appeared to be the coldest kind of its kind. As cold as the North Pole, actually.
Oh.
And only 7.2 light years away, which makes it the fourth closest star to our sun. Newly discovered.
I'm ready to go. Let's go.
All right. Brown dwarfs start off their lives very similar to stars, but, the collapsing balls of gas, but they don't have the mass in order to burn nuclear fuel or radiate starlight. This is one of those places where it's sort of the opposite end of the scale of, what is a planet? Everyone's like, well, Pluto got knocked off the list because it was on the small side. On the larger side of the scale, it's very large, super Jupiter-sized planets, and then brown dwarfs. It starts phasing into that. So, I mean, this one is estimated at 3 to 10 times the mass of Jupiter, which would make it the least massive of all the brown dwarfs known. So that's why it starts getting into that closer gray area.
Okay.
I mean, because of that, it could just be a gas giant planet that's been ejected from a star system.
Uh-huh.
But they think it's probably a brown dwarf because, as far as we know, brown dwarfs are going to be more fairly common than some sort of planet like that. In this case, it's throwing the statistics says, yeah, it's probably a brown dwarf.
Okay. So that's interesting. So they're calling it based on, well, odds are, basically?
Yeah.
Okay.
Yeah. What they see, and then from that, odds are.
Right.
But, I mean, this is the coldest brown dwarf out there. I mean, it's literally as cold as the North Pole. Minus 54 to minus 9 degrees Fahrenheit. That's minus 13 to 48 Celsius. So it's, in order to do this, you really can't view it with visible light telescopes. It is invisible. But you have to get it, you can kind of use thermal glows. You can use it in infrared light. You could barely get it. And so the NASA's infrared, Wide Field Infrared Survey Explorer, WISE, and another space telescope, they were able to kind of spot it by, they've been scanning the entire sky with infrared light. And this one was like on the second go around, and they were finally able to kind of spy it out. If you check out the video in the show notes, you can actually see where they see it moving a little bit. So it was very indicative of how close it is.
Very interesting. A brown dwarf star, huh? Well, there you go. I've never heard of such a thing, but
I was always very interested in that side of the scale in college, the brown dwarf or super Jupiters.
Right. Yeah, that is pretty fascinating. All right, Heather, well, watch out, because guess what? We got some SciByte viewer feedback, don't we?
We do. A couple weeks ago, SciByte 125, I was talking about Opportunity Rover and how its solar panels got cleared away. We had Michael Vallon from the Twitter typing me about some pictures that actually came out that I was really excited about.
Oh,
So
cool.
So what happened was that Opportunity Rover that's one of the older rovers, but still chugging along. Curiosity is getting all the major stardom, but Opportunity is still working hard. And it works by solar panels. And of course, over time, it's going to get more and more dust over it. And in this case, it got a 70% boost in power over the course of a few weeks, probably because of wind or possibly a dust devil flying over it. I mean, we've seen things like that happen before in its history. So we just had another one happen, and this is sort of getting on to springtime. So springtime also allows for more solar power. So Opportunity Rover's got a lot more power going for it for the near future for this spring. So, and you have to check out the pictures in the show notes or in the video. The difference is amazing. It's like
Yeah.
somebody went over there and swept it off.
It's like those commercials where they show a vacuum that vacuums up like a dirty section of the carpet and you have one clean strip. It's like somebody went over there and vacuumed off the solar panels.
Yes, so I always love it when those type of things happen. It's only happened a few times, but it means there's a huge power spike and the rover's lifetime really gets going again.
Love to hear that. Well, Heather, while we're over on Mars, should we do a curiosity update?
Let's go.
And liftoff of the Atlas V with Curiosity.
Touchdown confirmed. We're safe on Mars.
All right, Heather, what is our favorite rover up to?
All right, the first ever asteroid image from the surface of Mars was taken by Curiosity.
Oh, awesome.
Now, it was not just doing it for the heck of it. It actually was part of an experiment checking the opacity of the atmosphere at night because there's water ice clouds on Mars.
Uh-huh.
And so haziness can develop during the season. So in order to kind of check on that, they take pictures of the sky. They were able to catch a couple of stars. And in fact, the two Martian moons, Phobos and Deimos, were actually the main targets of the night.
Okay.
But they went through and they chose a time where they could actually catch two asteroids, Ceres and Vesta, in the same time. So they appear as little streaks. But that's because it's a 12-second exposure.
Right.
So that starts moving a little bit. The Ceres is the largest asteroid, and Vesta is the third largest object in the main belt. So in the same picture frame, they're able to see the smaller of Mars's moons. Now, you could see the larger moon as well as Jupiter or Saturn, but they were pointing in a different direction at that point in time.
Right.
But actually, you could, if any of us were standing on Mars next to Curiosity rover, we would have been able to look up and see those three stars, and we would have been able to see those two asteroids with normal eyesight.
Wow, that's a cool visual.
Yep.
I'd like to be standing next to the rover. That'd be great. It's a busy sky is what you're saying on Mars.
Yes, and on Mars, actually looking down has been busy too. They are getting ready to use a couple of tools this weekend to inspect a sandstone slab that's being evaluated as a possible drilling target. We've been kind of moving forward with this over the last couple of weeks. They found a nice little place. Now they're looking at possible locations. Now they're getting closer to this specific sandstone slab. Now, so far it's met all the criteria from the engineers and the scientists to become the third drilled rock on Mars. Now, the other two rocks were mudstone. So this would be the first type of different sand.
Okay.
So they have, so far everything's good. They have a couple of things they need to observe it with a little bit closer with the camera, with the X-ray spectrometer. At the end of the arm, they'll go out, they'll kind of brush a little spot of the rock away, take a look at, fire some laser shots at it, take the spectrographic analysis. So there's all sorts of steps going forward, but so far we're getting closer and closer to actually drilling into this bit of rock.
That's exciting.
Yes. So the other ones were letting us know, how the mud was going. Now, and how the ancient lake bed environment had, key chemical elements to provide an energy source that could have favored microbial life. Now, with this one, they're hoping to learn a little bit more about the wet process that turns sand into sandstone. So this is the process that makes fluids bind the grains together.
Wow.
Now, it could, in fact, also give an idea about, it could help explain some of the major shapes in the landscape where they are. Because, you have harder sandstone, and then the wind and water float, passing by rock starts to erode the weaker. So then you have these pillars or hills or things where it's the harder sandstone, which kind of is shaping the landscape itself. So we're able to check out this different type of rock, get a little bit better information about the process of this lake bed and how everything was going on, and get a chance to kind of get an idea about why we see certain shapes in the landscape.
Very cool. And don't forget, you can also tweet at the Mars Curiosity rover at Mars Curiosity, which is it's crazy. I mean, I'm sure you're not tweeting the actual rover, but it's still a neat thing. You get to tweet the people probably operating it.
Yeah, it tweets as itself.
Yeah, in the first person.
Yes, it does.
Yeah. Heather, good news. Over the weekend, since I was out and about at Linux Fest Northwest, I left the time machine here in the studio charging. So why don't you jump in, close the door. Let's go.
And lift off.
What? Not that one. No, hit this one.
We are lifting off into the past.
We are. Oh, it's bumpy. I'm sorry. I think I overcharged it. Holy smokes. Holy smokes. Wow. This week it brings us 239 years ago, May 2nd, 1775. Heather, what happened this week in science?
Benjamin Franklin completed the first scientific study of the Gulf Stream.
Oh.
So what he began in 1769 was to, as the deputy postmaster, was to notice ships took 2 weeks longer to bring mail from England than was required to go in the opposite direction. So then he's like, okay, well, now let's take a look at the specific routes that all these ships are taking and figure out why this might happen.
Mm-hmm.
And why this might happen is you have giant, the streams in the ocean going around. So
Right.
if you're going with the stream, then you're going to go faster. If you're coming back against it, then it's going to take longer.
There you go. And it started a pretty fundamental discovery of how the Earth mixes was discovered because somebody wanted to know why the mail was taking so long.
Yes.
Hey, you know what?
Mail.
Yeah, you got an itch to scratch. You got an itch to scratch. You want your letters. You want your letters. They didn't have email back then, Heather. So
Really?
that's all they had. I know.
Yep.
All right, well, let me recalibrate the SciByte 2000. That way we can look up into the sky this week.
Alrighty, this week we have Venus as our morning star. Looking east as daylight approaches, you'll be able to spot it. Mars is, in the meantime, high in the southeast after dark. Was going to be Spica below it, which is a giant blue-white star. And they'll be at their highest point around 11 p.m. daylight savings, moving towards the northeast as dawn approaches. Those are always a good pair. Totally, unbiased opinion.
Right, of course.
Because Mars is, nice red-orange spot, and Spica is nice blue and white, so they always make a good visual pairing there.
Right.
We also got Jupiter. At twilight, you'll be seeing it high in the southwest, sinking towards the western horizon as the night progresses. It'll be setting around 1 a.m. And Saturn is over there towards the end of twilight as well. Highest in the south around 1 a.m. And that actually will be at opposition next week. We had Mars at opposition a few weeks ago. That is when Saturn will be directly opposite the sun as far as the Earth is. So that'll be another all-night tour of Saturn coming up very soon.
Oh, wow, great. I look forward to that. All right, Heather, does that bring us to the end of this week's broadcast?
I think so.
Okay, well, very good. Don't forget you can catch SciByte live on Tuesdays over at jblive.tv. We kick off around 7:30 p.m. Pacific. You can get over at jupiterbroadcasting.com/calendar for the exact time. And Heather, thanks for the great show.
Thank you.
And thank you, everyone, for tuning in this week's episode of SciByte. We'd love to see you right back here. You can also download it on Wednesdays. It's published then. And you can also subscribe to the RSS feed. And then you just get SciByte automatically every single week. And speaking of having a great week, I want you to have a great week. And we'll see you right back here next week.